All right. Today is October 22nd, and we're having a uh, presentation today done by Cameron Banga, who is a ValpoHacks organizer and app guy. I will let him take over from here.
Thanks, Miles. My name is Cameron Banga, and today I am going to talk about making applications for the iPhone and Android. A bit of background on myself: I actually started making apps back in 2009. So when I was still enrolled in college, one of the things I did on a summer vacation with some friends was we made our first app for the iPhone. And then since that time, I, from one way or another, have been working in the mobile application development space. So I think technically I've made over about 150 applications. And typically I've worked as a project manager, designer, done programming, and kind of worked throughout the entirety of the mobile application development landscape. Um, Mobile apps have changed a lot in the last 10 years. And getting started today is very different than when I started back in 2009. But for today, I'm going to give a kind of a introduction to mobile applications, talk a bit about how to get started, and then offer some tips for anybody who maybe wants to take a look at this themselves. So it'll be very high level. You don't have to have programmed anything in the past. And from the audience here with me today, I'll get going. And then if there are questions, if anyone wants to throw one into the chat or something like that, I'm happy to answer those once we get going. And Miles, feel free to interject if somebody says something or whatever, if something comes up in the chat, and ask me questions when it's appropriate. So the first thing is that I want to talk about is, I guess, what makes a mobile application different from a web application or other programming. So the one thing that classifies, that really made mobile application development different than other types of programming was, for many people who got into programming, the mobile phone, be it an Android phone or an iPhone, was the first really hardware rich, fully featured device that people had programmed with. Um, for a lot of people, maybe building a website or building a web application is a really neat, interesting foray into development, where you can run a server, you can create logins, you can create these portals, you can do whatever you're looking for on a website. But in a mobile application, it became very interesting, exciting, because all of a sudden, developers were given these devices that had a whole variety of different unique ways to input data. They were touchscreen devices, so the interfaces could be fully featured or contain any sort of information you were looking for at the time. They could be customized UIs. And interestingly enough, they could be tied into certain properties that didn't exist on desktops. For example, compared to a laptop or desktop, you knew because it was a cell phone, it always had an internet connection, essentially, right? So you could build these applications that depended heavily on pulling in data. You could do mapping with GPS. You could do photo manipulation because you had a camera. Lots of different types of applications were first possible on a phone, and so users became, ever tied to the phones and their applications. And then the development environment kept growing to gain additional capabilities, functions, and all the sorts of things that we are familiar with on modern smartphones today. So the first thing we're going to talk about, I guess, is how do you get started. So there are two primary platforms for mobile development, and I think everyone's pretty much aware of them at this point. Apple has the iPhone platform, and then Google has the Android platform, right? So between those two operating systems, you see pretty much essentially all smartphone applications or users falling into one of those two categories. From Apple, they call it their Apple Developer Program. Google has a very similar program. For an introductory user here, this is the Android Studio Google Developer Program. The first place you want to get started, and I get asked frequently of, I want to start working in mobile development, I want to start programming. Where do I start? And the first suggestion I usually give people is find the platform that's most familiar to you, find the platform you use, and then find a program or some sort of problem that you want solved for yourself. That usually is the number one way to keep motivated through learning a platform. For example, if you run an Android phone every day, it's going to be very difficult to find the motivation to build applications for an iPhone which you're not familiar with using, or vice versa if you're an iPhone user. So usually the first step is to figure out the platform you're working on or that you're familiar with, and then start building there. Additionally, like I mentioned, the goal of building something that has use for yourself gives you motivation intrinsically to keep working on the problem, right? So, for example, if you're working on, hitting an exercise goal, maybe building a workout application that ties into that goal might be a really good starter for you to help give you motivation because you could use your application every single day. If you're looking into building a game, I mean, build just the idea of sharing that with your friends and playing it might be enough incentive for you. In application and software development, there's often this word called dog fooding, which typically means that the development team or the programming team is eating the dog food of the application they're building, right? So, for example, a team building the camera application on an Android phone or iPhone presumably will use that camera to take their own photos. So they have incentive for themselves in order to keep building and making the application better. So that's what I usually advise. Today we'll go over a brief overview of both programs. But basically, if you want to get started, the first place you should go is to the developer portal. So for Apple, they have developer.apple.com. For both Apple and Google's Android developers, a lot of this information is free. However, both programs, if you want to release something onto the respective stores, do require a membership fee in order to submit your first app. So when you go to these websites and portals, basically what you're looking for is the developer tool set. So you've got first an IDE. For Apple, they use what's called Xcode and currently is in version 12. For Android, you're going to be using what's called Android Studio is your IDE. And we'll show that in a second here. Additionally, all of these programs are going to include a lot of documentation, information on the various programs, their platforms, the latest releases, and then how to best take advantage of the features and functionalities of the software. And these will be very platform specific. So for example, here I'm currently at Apple's developer site. They'll have documentation as well as software downloads. So we'll take a look at what happens when you go here. So the documentation, this is really where you'll spend a lot of your time. You'll be looking at here, for example, let's look at Apple. One of the things that they've done is released in iOS 14 a feature called widgets. So Apple's developer portal will give you an overview of how these work. They'll talk about new frameworks such as Swift UI, and then kind of give you a step-by-step walkthrough of how you can expect this widget framework or the new API frameworks to work. Again, these can be typically a lot of documentation as well as additional information on specific protocols and API endpoints here. So here you'll get an overview of what the protocol widget does, how it works, key components, and then you might get some more implementation and running examples. Likewise, you may see other documents here about creating your first widget, go from scratch, and stuff like that. Android, on the Android platform, you're going to see very similar experience. You go to Android developers, you've got Android Studio, which is the IDE. You've got information on Jetpack, which is kind of a build tool system. You've got Kotlin, you've got documentation. Same situation here. And additionally, one of the great things about these developer portals is you'll often get example source code, which can usually be one of your first and most important ways to step into a platform. So we're actually going to talk about that here in a couple minutes. But here with Android, you'll see that they've got a variety of different source code applications. So you can kind of look at something you're looking to do similar to what you're trying to build, and then see how Google or Apple's engineers have built that from scratch. So for example, here's a watch face demonstration that works on Android Wear. So you can actually see from example source code how to build this application, and it exists all available here. Another website that I like showing a lot of introductory users to that is a very great tutorial website is a website called raywenderlich.com. Ray actually was a programmer who, around the original launch of the iPhone and the iPhone SDK, started a website where he built his own tutorials. He became popular enough that he actually has built out this full-fledged website, and today does he has a whole team of developers who write books as well as advanced training tutorials and source code examples for all leading mobile platforms. So they've got iOS and Swift examples, they've got Android and Kotlin examples. They also dive into Unity, which is a game development platform. server-side Swift, which is a building and using Swift to run server-side applications, which is a little bit less popular, but also something people do. And then Flutter, which is a cross-platform mobile front end primarily, but also application development platform that works on both Android and iOS. And one of the things they've done here is if you use their platform, they've got, first of all, great books that they do both in print and PDF. So if you're looking to build something, for example, you want to learn Swift, they have some great books here that are available as in digital format as well as physical. And then they also have leading tutorials that usually typically do include source code as well. So if you want to learn, for example, let's look here at this, they've got an advanced map kit. Some tutorials are behind a paywall. So the subscription here, they actually do have some pricing and subscriptions that are very, if you're trying to get this into a career, it's usually a very good example. If you can get it, there's very few development resources that you'll find that are less valuable, or at least more bang for your buck than what you get with Ray Wonderlic. So it can be a bit pricey. It looks like it's about $500 a year currently for the professional bundle. But what you'll find is that they've got great development resources for getting started. So once you decide an application you want to make, what we're going to do here is jump into some iPhone applications that I have examples of here. Is you're going to be working in an IDE. So one important note that most people don't actually know is when you're looking to build for iPhone, if you want to build for iPhone, you typically will need a Macintosh. Apple's Xcode program and development resources only work on a Mac, which makes it difficult to work with on a PC. Some people will use Mac servers to compile their code and work in Windows or Linux, but that gets very difficult. Android Studio is cross-platform though and works on Android, Macintosh, or not Android, sorry, PCs, Macintoshes, and Linux. So let's jump into Xcode here. What I'm going to actually show off are a couple projects and what an IDE is. So an IDE, let's just start a new project real quick. An IDE is what's called an integrated development environment. And what this does is provides a variety of platforms that are tools set essentially to create your own application. So in Xcode here, I'm just going to cancel this and show it again. I'm going to go to File and then do a new project. And there are a variety of different types of projects you can build. There's projects, there's Swift packages, there's workspaces, which are a bit more involved and could contain multiple projects, and then playgrounds, which are a Swift tool. But we're going to build a project. So if we're going to start our own application here, we would start with this project. And what this tool does is gives you a template to start building your project. So for example, you could build an iOS only application, a Mac OS only application, Watch OS only application, which would be Apple's Watch platform, Apple's TV platform, or other. These are typically would be some very basic and advanced options. But what we're going to do is just look at an iPhone app, so iOS. When you start in here, there's another variety of different templates. So you can have an app, a document app deals with the document storage system, games, augmented reality apps, sticker packs, iMessage apps, and then as well as some frameworks. So if we just hit next, we're going to create a new project. So I'm going to type out ValpoHacks demo. You'll select a team. My team is going to individually be myself. Applications on a mobile phone use what's called a reverse URL notation identifier. So applications, this happens to deal with the app stores. So applications need to be unique across. So basically what this identifier does is says, hey, my name is whatever my organization is. It's like .com, but you use the com first. You'll sometimes see edu dot or net dot, some sort of organizational identifier, and then a dot for the project name. And then across the app stores, throughout the app store for iPhone or for Android, what you'll find is that these identifiers have to be unique. And this offers Apple and Google give security that, hey, I'm the owner of this application. I have the ability to make updates to it, make changes, and then own that application in the store. When you're building a new iPhone app, you have some variety of different options here. You could do a storyboard interface, which is a legacy graphical user interface for building mobile applications. I'll show some of that off today. You also have what's called Swift UI, which is a relatively new technology for Apple. It was just announced during WWDC this summer. But we'll do a storyboard here. You can choose life cycles and then the language you want to program with. Most So Swift was a language announced and developed by Apple, I believe, back in 2015 or 2016. It's become the leading language for mobile development on iPhone platform today. Personally, most of my experience is Objective-C, but Swift has become the leading language, and for doing iPhone or iPad apps, Swift has become very prevalent. You can also choose if you want to use Core Data here, which is an Apple develop or database technology. Core Data is kind of a layer on top of SQLite, if anyone's familiar with SQL here. And then you also has the ability to use CloudKit, which would be a cloud backup storage of your data, so kind of a syncing tool, and then include tests. So what I'm going to do here is just create this. I'm going to create a example project and then run it. So one of the major differences between a mobile application and a web application is that when you're dealing with a web application, in most situations you're dealing with like an interpreted language or software that's running live on the server by just uploading the file. So most of the time people might use a build system where if you're using something like Docker or Kubernetes, you're kind of deploying an image and that's running live on the server. Or if you're using maybe a Python environment, you're used to using Git to manage that system. When you're dealing with a mobile application, both for iPhone or for Android, you're dealing with a compiled binary, which makes it kind of a different situation where you're actually compiling a piece of software, shipping it off to Apple or Google. Those companies are reviewing the software and approving it for the stores, but you're dealing with a compiled binary. So um, you actually have a situation where you're dealing with a bit more complicated of a technical process. So here is just show you the IDE. So this is Xcode, and what you've got is a very simple user interface here where you've got a left panel here. This panel here is usually, I think, called the project navigator. Yeah, where you can see the files that are included within the project. So this is your project, your full project here. And then inside of it, I've got various repositories. So I can basically directories. I've got the application directory, which contains all the Swift source code files, a storyboard file. Again, for Apple, this has become kind of like a storyboard is uses what's called an Xcode interface builder here to create UI. This is one way users or developers can create complex interactions. So for example here, I can kind of use this drag and drop infrastructure to basically create a user interface for what my application is looking to do. So I'll include the slider here, and then maybe let's just do a segmented control. And this is all drag and drop. And then you can actually write your code in your view controller to correspond to that. Swift UI is a more declarative. You've got to actually write the interface code, much like kind of like writing HTML, where you'll actually write the code of how you want your buttons to work. And that's a new release from Apple as of this summer, and is a relatively neat way to look at writing interface code. In here, you'll also see basically an assets folder. This is for your app icon, different colors. This would be your interface items. It could be pictures, it could be 3D rendering models, it could be sprites for Apple's Sprite Kit, which is a way to build game sprites and other information. You have your information.p list. This includes a lot of metadata about the application. This is a basic way to set certain requirements. For example, here I can set my orientation, the way that the device can be handled. And then you've got test folders and UI tests, and then eventually you have products, which are the application you build. So I'm actually going to hit the run button here. And then with my simulator starting up here, you're actually going to see this label get started. So actually I built this not very well defined for my screen size. So I built this to be an iPhone, for an iPhone 11. So one of the things you can do is you start building constraints, and then this is how most application UI designers will build this. So I've centered that label. I can actually do similar here. And this is building different interfaces to correspond with various different UI screen sizes. So I'm actually going to run that there. And then now my label has now decided to shrink in size. So I've got to give it a width constraint. And then now let's see what happens when I run it. Oh, the width constraint doesn't match. So it's probably got conflicting constraint issues here. But you can dive in and build user interface this way. And then essentially what you're looking to do here is if you want a new file, you just say new file. You can add a variety of different types of files. You can add SwiftUI files. You could add data models, different game implementations, or just straight C files or Swift files into the project. And it's usually just as easy as going example Swift file, putting it into the project and hitting create, and then it'll build that file for you. Android Studio is a similar IDE. This is built off the JetBrains platform. So if anyone has any experience using some of the JetBrains IDEs for other programming languages, it works very similar. This is an example Android open source project that I found called AnExplorer, which is a popular file explorer. And Android Studio runs in a very similar manner, where you have basically your file loadout here on the left. You can drop into various different directories which contain Java files and resources. Let's dive in and see here if this one uses, let's just go to a provider. So this is a Java written application. And then on the right here, you've got primarily your text editor. And then below here on the bottom part, you've got your build and sync operations. So very similar here. The computer I'm on actually, we just got this Java emulator running, or this Android emulator running. One of the key components of building an application on any mobile platform is you've got to basically be running an emulator. So I've got 3 of them running here, an Android emulator and then 2 iOS emulators, or simulators, excuse me. These will be used to emulate or simulate the device you're using. So that way when you're building your code, you can run the application, switch through all the various tools you're using, and then test your code before it releases. So again, Android Studio is the main Android IDE, and then iPhone, or for the iPhone platform, iPhone, iPad, we're using Xcode. One of the things here, I'm going to build a game here really quickly. So let's take an iPhone 11. So most development you're doing here is going to be essentially building and then rerunning. So this example here, let's close this simulator. Let's close, oh, that's fine. 1 second here, got too many things running. So this is a game from actually the Ray Wunderlich website called Snip the Vine. It's kind of like this cut the vine game, where the goal here is to release and drop this pineapple into the crocodile's mouth. So one of the benefits here of running an emulator, one of the benefits here is Xcode has this really well. Sorry, this audio here. I'm actually going to stop the audio, but it keeps playing a game soundtrack. So one of the things you're looking here is that you're dealing with Synthvine, and you've got a really good example here from Ray Wunderlich's website, as I mentioned earlier, of how a game would run on an iPhone. So you've got your various classes here, which are running the different games. So you've got the games app delegate, which is kind of the overlying controller that says here, basically, we take control of the screen. And then a game view controller where you can walk through and see how the actually Vine data and the Vine node. So this is developing actually how the Vine segments work. This is all written in Swift. And then a game scene controller. So you can actually see here where the game scene gets started, and then written here actually marks here, so you can actually see. So here's where the vine is managed. You can set up the vines. You can see where the crocodile's managed. Here's the crocodile sprite nodes. And then as mentioned earlier too, there's also this assets controller. So you can see here where the different game detailed controller information is. So this controls it. Outside of that, there's a variety of different signing and information when it comes to submitting an app to the App Store. And these IDEs manage this for you as well. So this here is targeted only towards iPhone, supporting iOS 14.2. It shows how you can handle device orientation, as well as status bar styles and stuff like that. So if you're wanting to get started with mobile application development, there's a variety of different ways to go, as I mentioned. Um, but the key to get started is, I think, heavily is figure out the platform you want to work on first. For me, when we got started with this 10 years ago, it was iPhone. I had an iPod Touch. My friends had iPhones. So it made sense to build something that was familiar on a platform that we've been using. And then from there, really just find out what sort of application it is you want to build. And then pile over the free resources available in order to get an idea of how you want to get going. So I typically would advise to most people is look here and just take a quick Google, figure out, for example, if I was looking to build a new application, I would say, okay, Apple's got this sample code library here. This is all recent from 2020. It's very modern, and let's take a look at what we've got. So if we want to build something with widgets, Apple just announced widgets. They've got all of this new code. So here I can download right here, and they've got a sample library that includes all the information, or at least a sample project that I can use in order to actually create a different. So this is building a widget. We're just going to go to the final version of it. It's called Emoji Rangers. Trust and open. And so Apple's built this demo source code, which can be run on any of these devices. I'm going to run it on my iPhone 11 simulator and see how it works. And essentially, once you have these simulators running and you've got this sample code, you have a full, basically plug and play sample of what it is you're trying to build, and which you can emulate or try to copy and figure out how Apple's done or Google has done the things you're looking to do. So for example, here it looks like they've got something called Power Panda. It's a game with characters, and what this is probably showing here is if I hold down a new widget library here. So here we go. So for example, if I wanted to build a widget for my application, I might take a look and say, well, how are they doing this? We're going to look at the views here, and then here's the actual widget. So it looks like what they've done here is that they're actually building. Let's see if I can resume this, if this will work or no. So their widget's actually built through a widget provider, and then you can see here what they're doing to build the entirety of the widget. So it's got a foreground color. So maybe if we take a look at the simulator. So if I wanted to change this to blue, and it looks like the color is a game background. Jump to definition. So actually here's where the colors change. So I can see if this is doing a different color management here. So let's just change that. So I think I'll then build a new version. Then actually, I think once I quit, let's see if that'll. Yeah, so then making these changes here will actually make changes to the game background. They have an avatar view. And then from there, you can learn more about how to compile the application. You're just running on your simulator, and then making changes. So it looks like we've got these characters, and then all the different parts here that make this application what it is. Another valuable resource both Apple and Google do is that they both release around every summer. They'll do a development conference, and then all of these videos, both Apple and Google have a multitude of videos available in order to learn more about the development platforms and how to code for them. So here, for example, are a bunch of Apple's videos from WWDC this year, and then Android has a conference called, or Google has a conference called Google I/O. At that conference, which you'll find, and this is available, I think, as well in video on YouTube, they've got a variety of different talks on how to, I'm not finding them here, how to program for the platforms. And then one last thing that I was going to give an example of is GitHub. So another valuable resource when you're getting started is looking for open source apps in the community that can give you more information on a various type of specific application you're looking to build. So one of these two resources I found this is from DK Hamsing called Open Source iOS Apps. And then there's a similar open source Android apps by PCQ. And what these GitHub repositories do are link to a bunch of variety of open source applications that you can use as a demonstration or for learning. So for example, here, if I wanted to build a business application, they've got, looks like business is not that popular of a category, but let's look at finance. So there's a variety of different finance applications. Here are some Bitcoin wallets, for example, or some, here's an expense tracker. So this application is a bit dated, it's 6 years old, but these would be full application source codes that a developer could use in order to get an idea of how to build common application types. For the iOS library here, for example, if I scroll down, if I wanted to build, let's say, a calendar application, here's a lunar calendar called Lunar Core. So this one's been updated as of it looks like it's a little bit old, 2 years old. But this has a lunar calendar with widgets that I can build and have built into iOS. This one's in Chinese, so it's a bit difficult for me to understand it, but here's one called Free Time Picker. And then additionally, on top of having all this free source code available, you often see these tags here, which will tell you this is a Swift app versus Objective-C app. And then additionally, if some star ratings to show which ones are most popular. So that's what I had for a initial overview of mobile application development. I guess I'd open up to questions and see if there's any interactive time we could have here with the group to see if there's any questions I can answer or how we could maybe get in a little bit more detail.
Daniel wants to ask why you're not a fan of dark mode.
Daniel wants to know why I'm not a fan of dark mode. I use dark mode actually heavily at work on most of my stuff. The themes here, I usually go with default themes. So the only reason, so if you look at Android Studio, I always use that. Xcode actually does not prompt you for a theme when you start it. And if it's not prompted, I usually go with the classic theme. I also just use the standard themes because I usually install and reinstall all this software all the time. And so if I get used to something really configured, especially then if I get to like a customization, I usually can't figure out how to get that reinstalled back on when I have to reinstall a new computer. Anything else?
What was your first project, the one you mentioned? Did you say what it was?
Sure. So it was an application called, I'll show you. It was an application called Battery Go. So I'm gonna have to look for it, see if I can find something. Here we go. So here's PC Magazine writing about it back in, where was it? Oh, that's not it. It was back in 2009. It was an application called Battery Go, and what it did was, let's see here. Let's see how to find it. It would monitor battery life on the iPhone. So, for example, if you had it's so old now that you can't find application information about it. Let me see. So what the application would do is it would, let's see here. It would monitor your battery life. So what would happen is if it would show you a percentage of battery you had remaining on your phone. So back in 2009, all the iPhone would do was show you a percentage of your battery left. There was no percentage or anything like that. Here we go. This is a story from the NWI Times. Let's see if it's got information. I can't find the URL. Here we go. So the application was called Battery Go, and what it would do is it would show you, I'm trying to figure out if I can get there's no photos of the app, of course. But But what it basically would do is show you the percentage of battery life you have left, along with an estimate of how long you could talk on the phone or play games or something like that on the iPhone. But alas, it has not been alive on the store for a couple years now at this point.
I have a question from Evbert.
Oh, Evbert.
Chat's moving here. Gotta find it. Okay. When you're developing for iPhone, how far back of an iteration should you go?
That's a tough question. So for most platforms, I guess for most applications on either platform, iOS or Android, the logical wisdom would be to go as far forward as is reasonable. So Apple and Google both, let's see here if I can do Apple. So developers usually do adaptation rates. So it looks like this is across, usually this is over the first couple of days. But iOS 14, typically what you'll find, I think actually if you go to Android Studio, when you build a new project, it tells you what the current rate is of, let's see here, if it's a new project. Let's see, this would be a great example here, if it works. So let's build a basic activity. Kotlin, we'll do a minimum of. So here you go. So this will tell you what your application will run on. So basically, if you go back to 4.1, but if you go to Android Q, so your application will only run on 8.2% of devices. If you go back to 8.0, you'll be running on 60.8% of devices, down to 7, and you'll be running on 73%. The typical conventional wisdom is to go as far forward in the future as is reasonable. One of the things on Android that you find is that you typically see in the United States a different range of applications compared to maybe developing economies like China or India. So if you're focusing only on the United States, you can probably bump this number up to something like Android 7. For iOS, most developers, if they can, only support the latest and previous version of iOS. So for currently, it'd be iOS 13 and 14. You will see games and some other maybe applications that rely less on built-in frameworks that might go back further. In a game, you're usually using your own UI code or your own you're depending on a game engine. There's less necessity to use stuff like physical hardware or GPS or some sort of other software benefit that's tied to the platform that would need you to, or would require you or encourage you to go to the latest version of the SDKs. But typically on an iOS application today, I'd say, with iOS 14 released earlier this fall, I would recommend 13 and 14. For Android, I would usually recommend developers try to go to 7.0 plus if they could. But again, it depends on the application type. And Android does a bit better of a job than iOS. Android has what's called Google Play Services and does backport a lot of the improvements. So it's not that difficult to support something like Android 4.4 KitKat or 5.1 Lollipop, and then have some of the latest and greatest features. So,
got a question from Heather. Are the device simulators a part of the development programs you're using?
So yes. So Android Studio comes built in with this Android device, Android virtual device system. I'm actually having some issue here, so loading them can be a bit difficult. But basically here, this is built into the Android Studio platform. So all you have to do is download Android Studio and you have access to these. For iPhone, similarly with the simulators, yes, it's built in the Xcode. So there's no way to get one of these without the other. So yeah, they're all included. The development platforms, both of the development platforms also are available for download for free. So you can download and play with these to your heart's content for free. It's only when you submit an app that they're paid. So by downloading, you have access to all of these test applications, the simulators or emulators, and all the other information you need to get started with an application.
Question from Nick. Any pitfalls or gotchas you've found, as in stuff you just know is a hassle or whatever?
So that's a really good question. I think it could go on for hours to answer that question alone. Mobile development traditionally does have a lot of, it requires a lot of insular knowledge, which you can only gain from experience, which I think makes it a very difficult platform, or both Android and iPhone. It makes them a bit difficult to get involved in 2020. There's a lot of history involved with both platforms, and unlike a language on the, like, let's say something like a web application which is running in Node or Ruby on Rails or Python, one of the fortunate benefits of web development is that it's wide in breadth, and you've got a lot of different people working in different directions. So for example, you might be able to use something like a specific platform like Heroku or AWS or Docker, and those platforms have unique characteristics, but the general idea of web development is abstract out the language and the platform or framework so that it works anywhere, right? So you're using it wherever you can run server code. With iOS and Android, you're kind of stuck in both of the platforms. You've got this walled garden that requires Google and Apple to be the arbiter, and they're both entrenched in a lot of tribal knowledge that if you don't understand the platforms or you haven't been involved, there could be some big learning curves. One of the biggest ones, for example, to that question alone, Nick, would be App Store review guidelines. So both Apple and Google, I'll pick on Apple here because they're an easy target, but both Apple and Google have very similar and relatively wide-reaching review guidelines that if your application does not meet these guidelines, you cannot be released into the store, right? So these have all different types of requirements on a developer. Whereas in a website, all you have to do is rent or purchase a piece of server hardware, and you can put whatever website you want out into the world. For the app stores, both with Google Play and the iOS App Store, you kind of are at the mercy and requirement that Apple and Google allow your application into their markets, right? So, for example, Apple has a lot here to do that they're worried about, parental controls and kids. Um, Basically, what you're looking at here is a variety of different development guidelines. So if you're looking to build any sort of application here, you kind of have to, it gets into data storage guidelines versus, you know, if you're building a UI kit app or a watch kit app or marketing resources and guidelines. Even with Apple, they have human interface guidelines. So the application is supposed to look a certain way so that it fits in with the design structure of the store. And often, frustratingly so for most developers who are getting started, you're going to have to learn the hard way that it's either play, the game that Apple and Google wants you to play, or you're not going to be able to get into the store. So that's probably the biggest one. Um, the second major hurdle that I think most people don't understand if they've not worked in the environment is both Apple and Google are consumer goods companies who will be putting out new versions of their phones and their operating systems every year. And so you're going to be in a constant push in order to build the latest and greatest and to meet the requirements of Android. I think Android's on 11 now, Apple's on iOS 14. And next year will come a new version of Android and iOS, and you're going to have to constantly be keeping up with the requirement changes and all the stuff that goes along with that, which can be a bit of a hassle and hurdle for, especially for developers who come from a web environment where if you keep your website running on a piece of hardware, as long as the hardware keeps up and running, that source code will run forever. Doesn't have to be intervention.
That's all the questions I see in chat, unless someone has. Oh, we just got one. For everyone making a mobile app, it is a constant job making updates for Android and Apple. You cannot. You cannot what? That's confusing. You just make a single app and just not update it. Is it?
Oh, okay.
I. Okay.
Oh, I see. So I see what Everett's question is.
Okay.
So both application platforms do have a point at which they will pull your application that hasn't been updated, or if it falls too far behind. So that does make a situation. Now, typically, you may not have to update it, let's say every year, but there will be a certain point in time where Apple or Google will say you're too far out of date and you do need to update it. And typically that comes tied with, let's say here. So Apple does a very good job. Actually, Apple does a pretty good job of this, where they do. Let's find this. They will do a program information where they tell you, hey, basically, here you go, news and updates. So they'll run through and tell you, hey, essentially, here are these deadlines you have to push to these new, let's say these push notifications are changing. You have to do these changes by March 31st, 2021. And essentially those are the mandates pushed by both Apple and Google. So yeah, if you don't update, you will find that your application may stop working. It may be removed from the store, um, and it may become inoperable, which is kind of a big bummer if you do have legacy code. And for a lot of niche applications that are side projects, that becomes a hard hassle to overcome every couple of years. But most of those changes come in waves. It usually would be something where certain frameworks that you're dependent upon change maybe once every 3 to 4 years, and you need to make the change at that time.
I think that's it.
Awesome. Well, thanks, Miles, for the chance to talk tonight,
Oh,
and I
thank you for
appreciate it.
talking.
And keep hacking.
All right.